liberty of tweaking the title of my talk slightly so that it's now the value of long-term field experiments to environmental policy, and I've sneaked in some slides about long-term monitoring as well at the end if I get time to get down to them, and I'll explain why if I do get time. So this just gives you an outline of the talk. Jerry's actually just covered some of the background, so that'll save me a little bit of time. Basically, I got involved coming out of work I was doing with our networks of heathland and grassland experts in the nature conservation bodies back in the early 2000s, and there was a feeling among the experts there that there were some incredibly important long-term experiments that we relied on for a stream of policy relevant evidence that were constantly under threat, but we didn't really have a list or a kind of whole picture. So I decided to do this inventory, and then that turned into a paper that Richard Jefferson and I had in British Wildlife in 2007, which was also about the time that ECT was really getting going. After that, my life took a different turn. I dropped out a bit, and I've been really interested since I agreed to do this talk in coming back and seeing what's been happening. So that's the background really. I'll just to outline the rest of the talk. I'll spend quite a bit of time actually talking about the context of evidence for policy because I think it's important. And then I'll sort of a quick overview of some of the key policy topics that long-term experiments can reveal. I'll gallop through some examples. And then if there's time, I've got a few slides about long-term monitoring, but I don't promise that anything that I'll get onto them. I should just say before leaping into the content that the views I'm expressing here are my own. They're not necessarily JNCC's, but JNCC is involved in a lot of evidence and data which is used to inform policy for the UK governments. So moving on, so that I'll spend a bit of time on this slide because it's I hope clarifies some of what I want to say. It's an attempt to answer the question, where does the evidence that we use for environmental policy come from? And roughly speaking, it comes from all sorts of different types of scientific endeavours. Just going through the sort of yellow bits at the top. Oh, I've got a pointer, haven't I? If I care to use it. So these bits at the top here, applied science, traditionally a lot of this was actually funded from departments or through the institutes, but increasingly actually a lot of applied science is now and policy relevant science is now funded through the research councils and through particular calls and strategic focus calls and so on. Also, of course, businesses and philanthropy can fund some of these endeavours. Best practice, just briefly worth saying a little bit about that. It includes things like professional standards and reviews. It's also things like conservation evidence website or what works initiatives and evidence-based conservation sort of initiatives. And then curiosity-driven science, which is like the blue sky science that traditionally the research councils funded a lot of, can be relevant. It is often relevant for policy. It's important because it can identify challenges and solutions at an early stage and also frame the need for and the benefits of change. An example of where blue sky science has led to important policies is the ozone research, which started off just as people studying the ozone layers high up in the atmosphere. They identified a hole, and that was identified to be a problem, and there's been some very successful policy interventions to tackle that. Getting onto the green blobs here, observational science that includes citizen science, and it's also got a lot of the data from our monitoring schemes or monitoring for compliance and impact. And that's a very big data set that we're lucky in the UK to have a really rich heritage of these sort of observational data records. And I probably should have said at the start of this slide, none of these blobs stands alone in isolation. They're all interlinked and overlapping. So, applied science and curiosity-driven science can use the data from any of those green boxes and often does and combines them. And there's very strong synergies between the different strands. And moving on to the controlled experiments, that's both long-term and short-term ones. Obviously, in the rest of this talk, I'm going to focus on the long-term ones. But there are they are uniquely powerful and important as a part of this picture. And I'm sure I don't need to tell most of you, but I'm going to say it anyway. This perception that correlation is not causation. So with the big observational data sets, we can, and if we combine them and look at other data sets about pressures and activities, we can identify correlations. But to actually prove a causation, you can try with some extremely sophisticated and slightly dangerous statistics, but the robust way to do that is to do a proper randomized, replicated, controlled experiment where you control, there is a control, but also that you can manipulate very carefully the treatments that you apply. And that really is the best way to show causation. And I'd say it's probably the only way to measure the effects that are caused by different drivers. So that's incredibly powerful. And all experiments don't have to be long-term. There's thousands and thousands of really brilliant short-term experiments that feed into our policy. But for certain processes that unfold over decades and perhaps involve a lot of unpredictable events and so on, a long-term experiment is your best bet to get the data you need. Just quickly speak very briefly about the analytics and the statistics. That includes things like data mining, so looking at heritage data sets to tell us things, and also sort of scenario testing, forecasting, hindcasting, and some of the modern modelling. And a lot of the modern modelling techniques, either statistical ones or the very mathematical and probability-based ones, need the information from all the other data streams to actually make the models work and to make them work properly. So that area, which is very modern, it's very live, it's very sexy at the moment, actually depends on all the other stuff, some of which is quite old-fashioned in a way. I just want to quickly say something about expert advice. I'm having trouble with my mouse. So expert advice tends to come for policy from our community of experts across government and academia. So it is a community, and it is it's not just policy driven by individual experts is usually quite a dangerous thing. Like, we're not particularly keen on that. So that there is a collective wisdom that people have, and it comes from their understanding of all the data that comes in from the different sources on this slide. But it also has the collective wisdom of the group that most of our experts are very well connected to each other, and also they are often hands-on practitioners who get out in the field and know the sites and see the places and have done the work. So they've got experience. They tend to understand policy needs and can explain the reasons and mechanisms for change. And of course, but in this post-truth age, we're all very aware of the risks of relying on expertise as well. The distortions that can be driven by our heritage and culture, by fashion, by ideology, by groupthink, occasionally by self-interest, and a number of cognitive biases. That's not to dismiss the expert advice. It's still a really important function, and a lot of policy relies very heavily on it. But we need to be aware of the pros and cons of being experts and of using expert advice. The last blob, I put it in grey to show that it's kind of out of scope. I'm not going to be talking about it anymore in this presentation, but it includes things like behavioural and motivational science and incentives for change and compliance, and framing the narrative, things and activities sort of measuring and understanding public attitudes. That's also really important for policy, but I'm not going to say any more about it. So I'm struggling to get it to go to my next slide. That's it. Okay, so the last slide about the sort of policy context is this thinking which sort of comes out of an EU programme around science policy interfaces, and they came up with this sort of very simple set of criteria for evidence for policy, which has got quite a lot of traction now, sort of gradually spreading out across the world, I think. And it looks really simplistic and obvious, but it probably isn't completely, and it is useful to run our thinking about evidence through this filter. So evidence for policy needs to be CREELY. So that's credible, So the science has to be of good quality, ask the right science questions, have a sensible hypothesis. The means to test it need to be valid and adapted to answer the question that's actually being asked. It needs to be relevant, so that's relevant to the users and to the government and responsive to the needs of policymakers and society. And the third one, probably most scientists don't have to think about very much, but it does become very relevant with policy, that it needs to be legitimate. It has to be seen to be fair and balanced when we have to be seen to be fair and balanced when we select and use evidence. And some of the long-term experiments, the outputs from them are quite controversial, or they have the policy implications of them are quite controversial. And when that happens, that's when legitimacy starts to be questioned and to be important. You can see if you can spot them as I go through the talk, before I tell you which one I think where the legitimacy becomes an issue. So this rather noisy slide, it was my attempt to go through the material on the website, also my own original inventory, and just see what sort of policy issues that the different experiments were feeding into, and it's very highly summarized. So most of by far the biggest number of experiments are in grasslands, and that reflects a very strong policy need to manage agricultural landscapes properly, but either for productivity but also for biodiversity. The column that says long-term monitoring to just is where there's some of the experiments, it won't be all of them, have actually been linked to in some way to a long-term monitoring endeavour. Either they're part of a long-term monitoring network, or they just have been kept going for long enough that they function as a monitoring point. Obviously, a lot of the grassland experiments are focusing very heavily on land management issues, so amounts of fertilizer, either manure or artificial fertilizer, grazing, mowing, restoration, recovery from degradation. There's a lot of those are the main areas that they're sort of producing results in. But a lot of them have been used to inform our policies around air pollution, particularly the critical loads, and in that case the nitrogen critical load. And a lot of them either are directly studying climate change and impacts on grasslands of climate change, or the long-term nature of them means that they're delivering information for us that's really useful for climate change. So I'm not going to go through in quite so much detail, but there's rather fewer heathland projects. They're a mixture of upland and lowland ones. They're interested in similarly fertilizer and grazing, but also burning becomes a manipulation to study. They've been very important for the critical loads and climate change. Peatlands, again, it's a mixture of uplands and lowlands. Similarly to grasslands and heathlands, sort of fertilizing, grazing, mowing, burning. A little bit of interest in seeding, and which means sort of using brash and things to return propagules to the vegetation in the hope of shoring up biodiversity. Also important for critical loads and climate change. I have not gone into so much detail with the woodlands. There seem to be about 4. I didn't have any in my original inventory, but there certainly are experiments looking at carbon levels of carbon dioxide around the trees, and obvious climate change relevance. ECT hasn't really covered freshwater and marine, so I thought I'd have a go. So in freshwater, there's a Lynn-Brianna experiment, which has been going since the early 80s in mid Wales, and that was an experiment looking at triggered by the acid rain issues of the 70s and 80s, looking at liming in catchments and the impact of land use, particularly tree cover, on the state of the streams. That's been very relevant to the critical loads for acidity, and has that got climate change impacts. And then finally, I haven't been able to find any marine long-term experiments. The Americans are very keen on doing experiments on shorelines and so on, but I don't think they're long-term. But there is an interesting long-term monitoring scheme that I'd like to tell you about, and that is particularly relevant to climate change and adaptation. So moving on now to the slides which are about particular issues and the experiments that have informed them. And this is where I'm coming from, I suppose, in my original interest in this area. So the sort of the outcomes, policy relevant outcomes we've had from all these experiments include things like prescriptions for management of reserves and farmland, so that the feeding in particular to the agri-environment schemes, certainly in England and I think probably across the UK. The schemes run through a series of sort of prescriptions and options that landowners can choose, and if they choose an option, then there's a prescription of what they have to, how they have to manage it to achieve the objectives, the environment objectives, and that's very strongly driven by some of the outputs of particularly the farmyard manure experiments, such as the raised beck and pentwyn. And that picture with the flowers is a picture of pentwyn, although it's not necessarily of the plots because I couldn't find one. And also there have been studies looking at restoration. The sort of classic one is the Upper Seeds Gibson plots near Oxford, which is the other two photographs, sort of an aerial view of the plots, and then a little picture showing how they had a control with no grazing and then treatment to summer versus autumn grazing. So that's those restoration experiments, and I think there's not very many, but a few of them. They've informed restoration advice, not just how to do it, but what to expect. In that, I think people have very unrealistic expectations of restoration sometimes, and it's shown, the long-term studies have shown that A, it takes a long time, and B, the vegetation goes through quite a lot of changes and phases before it gets to any sort of steady state or desired state. And so the message from the experiments is hold on, hang on in there, don't give up just because it doesn't look like the picture you had in your mind when you started. And also these experiments have given us information about sort of widespread pressures. See if there's any. Okay, so the next slide. Okay, so I'm still on the same subject of land management here, and this slide is sort of to show you the range of different levels of information. So I mentioned the agri-environment schemes. This is a manual for the higher tier countryside stewardship scheme, probably soon to be replaced by the environmental land management. But in there, there's lots of detailed, very technical information about how to manage, for example, species-rich grassland, what to do, what not to do. And that's very unglamorous stuff, has come from big experiments looking at farmyard manure and enrichment of grassland, and to understand what's advisable and what's safe. But on the right, that's a graphic from the Peatland ES study, which is also about burning and mowing. But it shows how policy is also interested in much wider catchment scale, landscape scale, ecosystem scale information, looking at multiple pressures, multiple benefits, trade-offs, and connected systems. And that is in itself a long-term experiment in the database, and it's delivering policy relevant information at a different scale, and they're both really important. The kind of nuts and boltsy, boring manure based stuff is just as important as the big conceptual evidence. We need it all, and then we need to integrate it. This is a fuzzy slide. I apologise for that, but it's the upland, moorland and grassland and heathland experiments in Moorhouse in the north of England. This was actually set up in the 1950s, in the glory days of when the Nature Conservancy Council was new. No, the Nature Conservancy was new, and there was a great deal of excitement about the use of NNRs for research. That was part of their function under the Act. And this was an experiment looking at different burning regimes of this heathland-dominated vegetation. So no burning, 10-year burning, 20-year burning, and then you may not be able to read it, but the black bits that show that where it was fenced, i.e. ungrazed, and the white bits show where it was grazed, so it was open and it was open to grazing. And those, in terms of applying the sort of Crelly criteria to this, that research is highly credible. I'd say it's done by the pioneers of a lot of ecological science, of post-war ecological science. They knew what they were doing. They knew how to design the experiment. They knew how to ask the questions. It's relevant because a 10 and 20-year burning rotation was fairly realistic. At that time, there is a perception that burning frequency has increased in the British uplands. And now I'd say, I think, that's quite a frequent rotation, frequent burning, 10 and 20 years. I think sort of in the northeast of England, it's fairly standard. Other parts of the country, maybe there's a much slower rotation. So it was certainly relevant. And this is one of the examples where legitimacy comes into the picture, because the British public have begun to think they might not particularly want areas of their countryside being burnt regularly, and there's a lot of concern about wider ecosystem services, particularly flooding and carbon, and so I started to question these sort of management regimes, and so that the issues become contentious, and with the is also a burning experiment. The results show a really complex response to controlled burning, and there's not a lot of evidence from them at the time, as far as I could find in a quick look, that there's a great loss of peat-forming species. So in terms of the original questions that were asked, the results are reassuring. But if you start looking at the carbon cycle, you might get a different picture, although it's still not very clear-cut. And there's some discussion of whether burning actually prevents nitrogen building up in the vegetation and litter, which might have some benefits. There's an interesting grazing story associated with this experiment too, but I'm not going to go there. So this is an issue where the credibility and the relevance are absolutely fine. It is legitimate to use these data and these outputs for policy, but it's not. A lot of the evidence then becomes quite open to interpretation, and that's where you have to make sure that you're being fair and objective. Okay, I'm not sure how I'm doing for time, doesn't look too bad. So I'll move on to critical loads. This is, for those people who don't know what critical loads are, this is about air pollution, and it comes out of a lot of work that was done at a European level to look at the impacts of airborne pollutants on biodiversity and nature and communities, which cover, and I'm going to focus particularly on nitrogen and acidity in my talks, but there are critical loads for ozone and other sorts of chemicals. So there's a little bit of a story behind this. In 2004, I organised a get-together of experts in lowland heathland and lowland grassland, and we came together, and one of the talks we had was from my colleague Claire Whitfield, who'd been working on critical loads for all the agencies for a couple of years, and she gave a presentation about critical loads and the impacts on heathlands and grasslands, talking about what was a safe level and what wasn't, and the evidence basically showed that there was a continual input of nitrogen to our wild habitats, which could damage some of them. And there were a lot of questions asked from the experts. There was sort of open-minded skepticism, I suppose I'd say, and one of the questions asked was, well, why haven't we noticed this? If all these sites that I know really well, I've been managing for years, are actually being damaged, why can't I tell? And there was a signal observable, for example, in the countryside survey data or in the work that Carly Stevens did and reanalyzing quadrats, and so I'm going back many decades. But on site, people weren't noticing any impacts, and that could be because the sites were really well managed, and you can actually ameliorate some of the damage from nitrogen deposition by very well organised grazing and occasionally mowing, and you can stave off the impacts, probably not forever, but for some time. But I think over the years people have come to understand that it's true. There really is an impact, and that the critical loads, they have come under some criticism. Some people think they're not precautionary enough, but they are basically sort of driving policy at the moment. So I had a quick look at some of the, not a complete selection of all the nitrogen addition experiments, but at some of them. Again, because I was thinking about, is it credible, relevant, and legitimate? So in 1986, DEFRA challenged their nature conservation advisors, saying, you keep telling us to stop farmers putting so much nitrogen on species-rich grassland, but where's your evidence? And the experts knew they were right, but they didn't have a lot of evidence just to present. So in 1986, the Teelim and Tatum experiments were set up, which ran for about 8 or 9 years, I think. And they looked at different rates of applying nitrogen fertilizer. They applied it for a few years, and then they monitored the recovery as well. So the highest level that they put in was 200 kilograms per hectare per year. And that's really basically the minimum that a farmer wanting to maximize their productivity would want to put on. They also had the great foresight, obviously they had a control because they were good scientists, so they had one with no additions, but they had the foresight to put in some lower levels as well. I don't know what their reasoning was, but it was fortunate. And then you can see the other experiments going through, sort of the Thursley 1, Thursley 2 was looking at much lower levels, Little Budworth looked at a range, but still going up to quite high. Then by 2002, interest had focused in on these lower levels, sort of between 0 and 50, I suppose. I think from memory, the critical load for nitrogen heathland is 30 kilograms per hectare per year. So if that's exceeded, we assume that there is some impact and damage. So you can see here that what was relevant in 1986, and I should say all these science studies are credible science, what was relevant in 1986 was 200 kilograms per hectare per year. But once the understanding of critical loads and of air, which obviously that's agricultural eutrophication, once the understanding of eutrophication from air pollution began to grow, people were interested then in much lower doses, and you can see that reflected in the treatments that were applied. I'm not quite sure with Thursley, they obviously went back up because they went to 30, which I suppose is about the critical load, so that I guess they were interested in impacts around that. And this is just, I won't read it all right out, but this was from a report in 2003, probably the same report that Claire was telling us about in 2004. And they were saying that there'd been some really good experiments, but there weren't enough experiments using low doses of nitrogen, and also that the experiments weren't running long enough. And also they point out for some ecosystems there were no experiments they could base it on, which is regrettable. I hope that's different now, but obviously it would affect our confidence in the outcomes. So now I'm going to move very quickly on to climate change experiments. I'm not going to spend too long. There's quite a few of them. They all manipulate temperature and water rainfall using gadgetry, some of which is on display here, sort of rain covers and irrigation, and cables to heat the soil, and lots of gadgetry. They tend to be interested in measuring the sort of responses of individual species and communities, as well as sort of physicochemical measurements that they might take. The results have been interesting and very policy relevant in what it tells us about the resistance and resilience of ecosystems to climate change. Of course, these experiments are all happening in a fast changing climate, and where the rest of climate change science is advancing very fast as well. So it's quite difficult to keep up with the amount of information that's coming in many respects. But I think they will, and maybe have already started, to inform our adaptive planning and land management, sort of climate change land management advice. And they can feed into forecasting, sort of linking ecological environmental forecasting with climate and meteorological forecasting. Just to tell you about the pictures, the top one there is Clocaenog, and the bottom two are the Buxton grassland, very long range climate change experiment, which is probably everybody's top 3 long-term experiments. It's great. Now moving on to freshwater, and thanks to Steve Ormrod for sending me these useful slides. In 1981, they started to look at the impact of acid rain and looking at ways to ameliorate the impacts. And they started in 1981. Now this is a replicated catchment experiment, but it's not a randomized grid square of the sort that we're probably familiar with. So because it's a catchment and they're looking at natural rivers, you can't just turn them into squares. So what they did was they added lime to 3 catchments, that one, and that one. They limed it for a few years, and then they also measured and monitored through for recovery. So the sort of policy relevant information that's come out of this was that the effect, that liming did have some effect, but that sort of diminished over 12 to 18 years. And they also looked at the impact of land use, particularly recovery, and on the forestry on recovery, and also particular climatic events. So they were able to detect differences in the acidity, higher acidity, reduced pH in wetter winters. So because they had a long-term approach, they were able to look at these sort of longer-term cycles. just there's one more slide. Oh, I didn't know that was going to come in like that. Don't know what that was for. I think I've maybe never looked at that slide in slightly performance view before. And then Steve's other slide just gives a bit of the background to the catchment is upstream of this reservoir. There's obviously concern about fishing, and they have turned that whole catchment into a sort of science observatory site, and there's been lots and lots of research starting from the long-term experiment, but not and using the data that comes from it, but not specifically part of the experiment. So they've done a lot of work on climate change adaptation there, and ways that we can sort of land use strategies we could consider. So things like refuges, protecting wetlands, planting trees for shade. And there, I've no time at all to tell you all the interesting science that's come out of this, as many of the other experiments. So the last few slides, I'm not sure how long I've got, but I haven't been given my 5-minute warning yet, are about monitoring. So they're less central. Yes?
Your 5-minute warning now.
Okay, I can do it. I can bring this in on time. Fantastic, thank you. So there's a few reasons I wanted to look at monitoring, partly because of the synergy between the experimental and the big data set sort of across the whole landscape. The synergy between those different data streams and the importance of having both, because they complement each other. But also because for a little while I was director of the UK Environmental Observations Framework, which is all about monitoring and surveillance data. But finally, when I asked colleagues around the conservation agencies for sort of for their advice for this talk, or how they felt that long-term experiments had impacted their policy work, quite a few of the responses I got back were basically saying, please mention long-term monitoring because it's in trouble and it's really important, and we struggle to keep it funded. And Penn did say that there's discussions about whether ECT should cover monitoring as well. It also, as an aside, gave me an excuse to say something marine, which matches my new job. So I won't speak for too long in my 5 minutes, but these are some of the monitoring schemes we have for freshwaters. The upland waters monitoring network used to be the acid rain monitoring network, so it links into some of the work at Brianna. And they are the ones in turquoise in that map, sort of lighter turquoise. And that covers rivers and lakes. It was basically tracked recovery after the policy of stripping sulfur at power stations. It meets all my criteria. There were some interesting sort of unexpected results. For example, that reducing the acid and sulfur deposition was followed by an increase in dissolved organic carbon in a lot of upland waters, which is a massive policy issue if you're somebody who needs to supply drinking water to people and they don't want it to be brown. There's been a lot of interesting outcomes about resilience to climatic events, including the one I mentioned earlier in Brianna. And also somebody said they find it really useful if the sites happen to be in a protected area because it feeds into our protected area monitoring. That's a small policy benefit. And then there's the other thing to mention here is the environmental change network, which is the blue dots. They're the freshwater ones, not ECN. There's lots of other sites in the ECN network, but those are the freshwater ones. And that's a really important national capability resource that we have that we need for policy in so many different ways. And then the last two slides are taking us away from terrestrial. I just wanted to quickly tell you about the continuous plankton recorder. That's a gadget shown at the top there. It's about 1 meter long, that thing, and it can be towed from behind merchant ships. It's got a sort of silk tape inside that catches plankton and continually rolls around, and then can be taken back to the lab. It's actually been going since the 1930s, but it's been a scheme, a sort of a sizable scheme since 1946. They've got an archive of their samples that goes back to 1958, which I think is fabulous. It is part of a global initiative, but actually most of the work's in the North Atlantic, as you can see in the map there. And there's loads of science that's come out of this. I've just picked a couple of things. It's really important for studying ocean health, particularly climate change, ocean acidification, and so on, and for tracking and looking at the arrival and impacts of invasive species, which do happen in plankton as well as in other species groups. And there's an example. Yeah, so this is my last slide with stuff on it. So this is just an example of the sort of outputs from the continuous plankton recorder. So this is an invasive alien species. It doesn't seem to be a particularly problematic one, but it's a phytoplankton. And you can see the sort of richness of data that can be generated by this system. The funny little symbols in the shapes, they show basically survey effort. You can see there's a lot more survey effort in the North Sea because there's a lot more shipping movements there. And then the purple shows the abundance of the species. And it's owned by the MBA, the Marine Biological Association. This thing now, it's had a long history of long and very distinguished history actually, and they struggle to keep it going because of the costs. It is still going, and I think they do about 8,000 nautical miles a year or something. But because of the costs of the lab costs really of analysing the samples and archiving them, they've had to scale it down. It was bigger. Which is a familiar story, I guess. And then finally, yes, I'm so grateful to all these people that have input information to me, the colleagues in the various nature bodies and the individuals at the end there as well. Thank you very much. So that is me done.